Okay, let's try that again. Alright, in the Cisco CCNA there'll probably be a question that goes something like this, very roughly, and they do this all the time, is the admin network has like 44 users, faculty network has 60 users, media network has 22 users, library network has 12 users. How do you want to subnet the network, right? You're given a network address. How are you going to subnet it, right? Well, and they'll say, what should be the subnet mask? And then they'll give you these choices and whatnot, and you have to figure it out. Well, here's the key issue. We're going to need, instead of having one network, we need 4 subnetworks, right? We need an admin, a faculty, a media, and a library network. So not just one network, we need to subnet it into 4 networks, right? So we're going to have to give it a very funky subnet mask, right? Well, first of all, all you have to do is figure out your magic number and you're all set. So the 128, if you were to take this last octet in this subnet mask or net mask, right, and you just do the 128 in binary, you see that it looks like this. That's in binary. The 192 looks like this. The 224 looks like this, and the 240 looks like that, right? Starting to do that. And then the 248 looks like this, right? Alright, and so the 128, the 1 is in the 128's place. Here we've got borrowed 2 1s, and 1 in 128's place, and then a 1 in the 64's place. Add them together, you get a 192. Here, 128 plus 64 plus 32 equals 224. Here, 128 plus 64 plus 32 plus 16 equals 240, and then 128 plus 64 plus 32 plus 16 plus 8 equals 248. So I do this and I ask myself, what's the magic number? And I see that on this one, the magic number right here is 64, right? Magic number is 64. Well, that's going to be enough hosts, just enough usable hosts. The usable hosts will be 62, and that's going to be enough. Let's see here. Gosh, can't stand this. Sorry about this, everybody. The usable hosts will be 62, right? So the magic number is 64. You can't use the first number, can't use the last number, can't use the network number, can't use the broadcast number. So you have 62 usable hosts. That's enough for the biggest of the networks that we have to create. Also, we've borrowed 2 bits, right? 2 network bits, and 2 to the second power is 4. So we know that there's 4 networks, and the networks are going to go up by the magic number, right? The magic number is 64, so the networks are 0, 64, 128, and 192. So you have 4 networks. You need 4 subnetworks, so you're all set, right? So what are the networks in this case? The networks are 0, 64, add 64, you get 128. Add 64, you get 192. And those are the networks. Let's see here. Yeah, there we go. I'll take that to the next line. There we go. So those are the networks if the magic number is 64. Right? 0, 64, 128, 192. Each network goes up by 64. Just add 64 more, you get the 4 networks. We needed 4 networks. We needed to have at least 60 users. With a 64 host network, we can do 62 usable hosts, so we're all set. So the answer is B, 255.255.192. It'd be the correct answer. Or, in this case, /26 is the amount. We borrowed 2 1s, and so that's it. That's the magic number theory. Okay, so in this next tutorial about subnetting, Cisco subnetting and subnetting and using binary, and we'll talk about the magic number now. We said, now, what if, right? What if we had this number, same IP address, 192.168.3.55, but it was /28? Well, what does that mean? That means 255, 255, 255, 240. Or here's the subnet mask right here, right? We've got, if we count all these ones, that's 24 ones. So this would be 25 ones, 26 ones, 27 ones, 28 ones. Okay? And so this would be the situation now, where we'd AND the IP address with the subnet mask, and this is a very different scenario. And in this case, we're going to now logically, we're going to do this AND operation. That is what happens with the router. And a lot of people, students will, it's often an easy time to say, well, just multiply the two numbers together. Multiply the IP address with the subnet mask, and you will get the same result. But it's really not a multiplication that's happening here. It's a logical ANDing. It goes back to logic and Boolean logic and all that kind of stuff. Computers, the logic behind computers works with binary number system. So what happens now is if we AND this together, we'll get the same result here, right? We'll get 192 in that octet. We'll get 168 in this octet. We'll get 3 in this octet. But when we get here, we're going to get a different result. So now when we AND these together, we're going to get 0 and a 0 and a 1. A true and a false makes a false. A false and a true makes a false. A false and a true makes a false. But here we go, 1 and a 1 makes a 1. A true and a true makes a true. And then another one, true and a true makes a true. Okay. And then we have here false. A true and a false makes a false. True and a false makes a false. So now we have a very different situation. We have the 128-bit, the 64. Okay, so we have the 32 and the 16-bit. So this now becomes a 48. And it tells us that when the router sees this number right here, right, 192.168.3.55/28, it means that the subnet mask is 255.255.255.240. It puts it into binary essentially, or it's in binary, and they get ANDed together, and it finds out that the network number is in fact this. The network number is 192.168.3.48, and that's a very different type of number. So now to talk more about this, I'll need to backtrack a little bit and talk about, well, network number. What is the network number? Why is this? And how is this working? Well, in every network you have the network number and the broadcast number and then the host numbers. So let's say you have this type of number and the subnet mask is normal, or what we would call classful. Okay, this would be classful. This would be /24, right? So in this situation, you always have to know, and in Cisco you're going to be asked to do this, what is the network number? Okay, what is the network number? What is the network number? All right, let me scroll down here. What is the network number? Well, in this case, the network number is 192.168.3.0, and then they'll ask you, what's the broadcast number? Okay, this is the network number. The broadcast number is 192. It's the last number in the network. The network number is the first number in the network. And so in this case, the broadcast number is the last number in this network. Okay, so 192.168.3.0 is the first number in the network, and this is the last number in the network. And that means that no host can occupy this number or this number. Nobody can be 0 or 255. So people on the network have to occupy the number range between 1 and 254. Those are the hosts. Okay? So every network has a network number at the beginning of the network, and then it has the hosts, and then it has the broadcast number. All right? And the broadcast number is reserved. Nobody uses it. And the 0 is the first number. The network number is reserved. Nobody uses that. Right? Okay, so that's if you have a classful subnet mask. Well, in this case, that means that these are all zeros. So the classful subnet mask was that. But we didn't do that. We borrowed 4 bits. 1, 2, 3, 4. Right? And In that situation, what happens is the last bit becomes the magic number. So the last borrowed bit that's not classful, right? Classful in this case would have been a 255, 255, 2550, or 24 ones and 8 zeros, but we have now added on these ones. These become the subnet bits, and in this case the magic number is the last borrowed bit, and this last borrowed bit is in the 128, 64, 32, 16's place. So according to this network, the magic number is 16. Alright, and what is that going to do for you? Well, I'll show you in a minute how that works and why that knowing that number 16 is so helpful. The last borrowed bit, why that is exactly so helpful. I'll do that in